So in this video, we're going to talk about molar mass and how to calculate it. And in your practice set, I believe this is 2.1. So the technical definition of molar mass is the mass in grams of 6.02 times 10 to the negative 23 particles of a substance. And while that may sound scary, atomic mass is actually quite simple. And I like to think about it as adding all the atomic masses. So adding the atomic masses of all the elements in a given compound or molecule. So this is the definition that I like to think of when I think of molar mass. And this atomic mass that I mentioned right here, you can get this from the periodic table. And it's all these little numbers that are below the different elements. And these are the known masses of a single atom of a particular element. So when determining molar mass, it's always important to have a periodic table with you. So let's jump right in. Oops, sorry. Alrighty. So whenever we think of determining or calculating molar mass, I like to think of 3 steps. And we have 1, which is finding the atomic mass of each element. So this is important. It has to be of each element. Number 2 is multiplying the atomic mass, and I'm going to abbreviate this as AM, right? Atomic mass of each element by its subscript. And these little subscripts are, for example, H2O. This is a subscript, right? So that just denotes that there's 2 hydrogen atoms in this molecule. And we'll get into that a little bit later in this video, but we're going to go through a few simple steps before we get into number 2. And lastly, number 3, which is adding up all the masses of the different atoms that make up an element, right? And then we're also, here is an important step or part of number 3, which is adding units. And whenever we're dealing with molar mass, our units are going to be grams per mole. Right? So this is very important because we're going to be adding this unit, grams per mole, after each of the molar masses, right? So units are very important because they let us know what we're talking about, right? So grams per mole is specific to molar mass, and sometimes it'll be written like this. Typically, it'll be written like this. So G is just for grams and MOL is for mole. And again, it's just really helpful to know what we're talking about, right? So say that we have, for example, we have 10 and we write grams per mole. It lets us know that we're talking about molar mass, because if this was missing, we could be talking about 10 anything, right? We can be talking about 10 hydrogen atoms, 10 heliums, 10 oranges, 10 apples. You wouldn't know what we're talking about. So grams per mole are really important whenever we're determining molar mass. Alrighty, so up here, I just rewrote the 3 different steps. So 1, find the atomic mass of each element. 2, multiply the atomic mass of each element by its subscript. And it's important to note that whenever there's no subscript present, and I use the example of H2O, right? So we said H2O. 2 is the subscript denoting that there are 2 hydrogen atoms in this molecule. However, oxygen doesn't have a subscript near it, right? It's missing a subscript. So whenever it's missing a subscript, all this means is that there is only 1 atom in this element, in this molecule, I'm sorry. And then lastly, we have step 3, which is add up all the masses and add units. And the units that we talked about were grams per mole. So let's do an example. Let's do carbon monoxide, right? Carbon monoxide is written as CO. And first step, right? Find the atomic masses of each element. Here we can look at our handy dandy periodic table and look for carbon, right? C, and oxygen. And right here we see that the atomic mass for carbon is 12.011 and oxygen is 15.999, right? So all we would have to do, and for these two, it seems like a big number because there's 3 spaces after the decimal. And depending on what your teacher may ask for, perhaps she does want all 3 spaces after the decimal. But most teachers typically just ask for 2. So 12.011 can just be written as 12.01. And then for 15.9, you can always round to 16.00. But for here, it's important to just ask your teacher if she cares about significant figures or how many spaces she wants after the decimal. So for our purposes, we're going to use these 2 just because they're easier to work with, right? So for carbon monoxide, we said we have 1 carbon and 1 oxygen. So step 2, multiply atomic mass of each element by the subscript. And remember, when we said that whenever there's no subscript, it just means that there's 1. So both of these lack a subscript. So we're assuming that there's just 1, right? So step 3 is add up all the masses and add units. So let's do the first part of step 3, which is simply adding, right? 12.1 for the carbon. This belongs to the carbon. Plus 16.0. And that belongs to the oxygen, right? So this equals 28.01, right? So we added up all the masses. And now it's time for step 2, adding the units, which is important. I can't stress how important this is. So 28.01 what? 28.01 grams per mole. And just like that, you determine the molar mass of carbon monoxide. Alrighty, so let's move into a different example. Let's do H2O. So for here, same thing. We're going to find the atomic mass in the periodic table. So we have hydrogen and oxygen. Step 1, done. Step 2, multiply the atomic mass of each element by the subscript. So here, what it refers to is, we know that we have hydrogen and oxygen, right? We have hydrogen and oxygen. But here we have a subscript, right? And this is where step 2 becomes really important because we have to multiply the mass that we see here, which is 1.0. We're just going to round, so 1.01 and 16, right? Because we rounded up from 15.9. And what I like to do is simply write the equation out like this. Set it out right here. I have the atom, the atomic mass, and then the atom, the atomic mass. And whenever there's subscript, I like to sort of make this little skeleton so that I can just fill it in with whatever subscript is present, right? So this one goes right here. And what this is indicating is that we have 2 hydrogen atoms. So that means that we're just going to multiply the atomic mass of hydrogen times 2. So that would be 2.02. We have 2.02 as our atomic mass for our 2 hydrogen atoms. And then we just bring this one down, right? Plus 1 atom of oxygen, which ends up giving us 18.02. And then we have to add our units, right? So here, this was step 3. And this was step 2, our multiplication. And lastly, we just have to add our units, right? Grams per mole. So the molar mass of water is 18.0. Alrighty, just so we get more practice with subscripts, we'll do one more example. So we'll do NH3. And we'll run through this one pretty quickly since we already went over the steps, but Step 1, look for the atomic mass in the periodic table. For nitrogen, it's 14.01, and for hydrogen, it's 1.01, right? And because of that subscript, we know that we're going to multiply the atomic mass of hydrogen by 3. And if you're plugging this into a calculator, I like to just go ahead and add all of this together, right? So that would be step 3, adding up all the masses. And when you plug this into your calculator, this will give you 17.04, and then adding our units, right? We said that was important, grams per mole. So the molar mass of NH3 is 17.4 grams per mole. Alrighty, so now we're going to move on to a few of the practice problems on your practice set worksheet. And we'll run through these again pretty quickly, just because we already have those steps down. So let's do the first one, right? 1, 2, and 3. So this is silver acetate, and we'll just start by finding the atomic mass of each element, right? So we have silver right here, which is 107.87, and we'll go ahead and do plus, and we have carbon, which we know will multiply by 2, 12.01. I'll make this smaller. Plus, we know we have 3 hydrogens, right? 1.01 plus 2 oxygens. And I hope this is sort of making sense and seeing how you can use the molecular formula, which is this right here, sort of as a skeleton for determining your molar mass. And whenever we plug all of this into the calculator, we get 166.91 grams per mole. Alrighty, let's do number 2, which is calcium carbonate. So again, we'll just go to our handy dandy periodic table, look for calcium, carbon, and oxygen. So calcium has an atomic mass of 40.08, and we only have one of them, right? Carbon, we have one of them, plus 12.01, and then we have 3 oxygens. So let's do 16.00, and that gives us a molar mass of 100.09 grams per mole. Our last example is magnesium phosphate, and this one's a little different than the ones that we've previously worked with, but it works the same way, right? And what we're going to do is that we're going to use the molecular formula as a skeleton for solving for molar mass. So what I like to do is when questions are a little complex like this one, I always like making my skeleton first, right? So we have magnesium, and we know that we have 3 of those atoms for this element, plus, and we're going to do a bracket to represent these, the parentheses that is around the phosphate. We have 1 phosphorus atom plus 4 oxygen atoms. We'll close the bracket, and then we see that there's 2 of these phosphates, so we'll multiply all of that by 2, and that will give us our molar mass. So all you have to do now is go to your periodic table and look for these different elements, right? So here we have magnesium. We have 24.31 times 3 plus, fill in the bracket, 30.97 plus 16.00 times 4, and then you're going to multiply this by 2, right? And this will give us a molar mass of 262.86 grams per mole. So hopefully this helps, and you see how you can use the molecular formula as a skeleton to help you solve for molar mass. And as long as you follow these 3 steps, you should be good to determine the molar mass.